So one of the things we're going to be going through right now is we're going to be talking about a simple beam deflection problem. So basically how it works when doing a beam deflection is you're going to have a beam that looks like this, and there's going to be a pin and a roller on either side, and that beam is going to be a certain length. Let's just say it is 12 feet, and there's going to be a force on it, and we'll just say that force is 500 pounds. Now, a couple of the other things they're going to tell you about is they're going to tell you either what the moment of inertia is, or they're going to give you some type of drawing that shows you the cross section of what that beam looks like on its end. So we'll just say this beam is 2 inches wide and it is 8 inches tall. And they're also going to tell you one other thing, which is going to be the modulus of elasticity for that actual material. So let's just say it's 1 million psi, pounds per square inch. So what we need to do is we have a formula that looks like this. It says delta max, and it is FL cubed over 48 EI, where F is the force, the L is the length, 48 is a constant, E is the modulus of elasticity, and I is the moment of inertia. Now, since they haven't given us I in this problem, what we're going to do is we need to find it. In order to find I, it is the base times the height cubed divided by 12. So that's where we're going to start on this problem. So we have I equals, the base in this case is 2. The 8 is the height. We're going to cube that and divide by 12. So what we're going to do is we're going to do 8 cubed, and we're going to get 512. So 2 times 512 divided by 12. So, and then we're going to do 512 divided by 2, and we're going to get 1024 divided by 12. And when we do that, we're going to get a moment of inertia for this beam, 85.33 inches to the fourth. So that's our moment of inertia. Then what we're going to do is we're going to put all these things in here. Now there's one key thing you have to pay attention to. You have to pay attention to a lot, but there's one key thing that a lot of people make a mistake on. So when we put this in, we'll just call delta M, just for short. So the force is 500. Now, I'm not going to do anything with that L yet because I'm going to talk about that L. 48 is a constant. E is our modulus of elasticity at 1 million. And our I is 85.33. Now, our L, we have to think about, we got to do something with. So this is in inches. These are in inches, which means this is in inches. Problem is that 12 feet is not in inches. So we need to make that inches. So if we want to break down that L a little bit further, we have to convert the 12 feet into inches. So it's going to be the 12 feet times the 12 inches in every foot. And we're going to cube that. So when we do that, we're going to do 12 times 12. And we're going to get delta M equals 500 times 144 cubed over. And I'm just going to do the denominator right now so we don't have to worry about it. I don't have to write all that again. And that's a pretty... So it's a big number. 409,584 and then 4 zeros. So essentially, it's about 4 billion is the value on the denominator. So let's do the numerator. So 144 cubed So delta M, and we get 500 times 29, 8, 5, 9, 8, 4, all over again. Now, I'm doing this kind of slow so you guys can see the process. Normally, I would not write all these numbers out. The key reason I wanted to do this, that numerator, separately, is I want you guys to see that that cube only affects this number. You're only cubing the length in inches. That's the only thing they're cubing. So make sure you pay attention to that. Definitely make sure you're changing it into inches. So we're gonna take that number, we're gonna multiply by 500, and coming down the end here, so delta max on the numerator is 149,299,2000, all over 409584000. Okay. So when we're going to do all that, 409584123 and we get a delta max of 0.3645 inches. That means that when you load that beam, given all that information, that beam is going to bend slightly. And that bend is going to be a distance of 0.3645 inches. That's how much it's actually going to bend. So, I'm going to have us do another one just so we're all on the same page and you can kind of see how it works. So I'm just going to do a quick erase right here. Right. And we'll do one. I'll show you the way that I do it. You can see kind of the way that maybe you could do it. So we have a beam here, and I'm going to do it slightly different just so you guys can see. So it's 1,000 pounds. The supports are this time 15 feet apart. This whole beam now is 20 feet long. We're going to say the E, I will just say it's 1200, so 1.2 million, and we'll say the I, in this case, we need to solve, so it's a 2 by 10, we'll say, so that's 10 inches by 2 inches. Yes, I know if you know anything about construction or anything about actual boards, a 2 by 10 is not 2 by 10, but we won't get into that discussion. Okay, so delta max equals FL cubed divided by 48 E times I. Alright, so here's the process I do. I find moment of inertia. So base height cubed divided by 12. So we get 2 times 10 cubed divided by 12. So 10 cubed times 2 divided by 12. And we get an I of 166.67. Awesome. Delta max. And what I'm also going to do is I'm going to figure out that length. So we're going to use the distance between the supports. Always between the supports. The fact that this is extending, it doesn't matter. You want the distance between the supports. So we're going to take that 15 feet and we're going to convert it into inches. So 15 feet is 180 inches. So we're going to take our 15 just to write it out here so you guys can see it. Make sure we have it. 15 times 12 equals 180 inches. Alright, so our force, 1,000 pounds, times 180 cubed over 48 times 1.2 million times 166.67. So I'm going to do that 180 cubed, and I'm going to get, it looks like 5,832,000, and I'm going to take that number and I'm going to multiply it by our 1,000, and we're going to get a big number. So 5832 and 6 zeros. So 5832 and 1, 2, 3, 4, 5, 6. 6 zeros, all divided by 48 times 1.2 million, 166.67, and we get 96,001,92,000. So we take those two numbers and we're going to divide them into each other. 96,001,92,000. And we get a delta max of 0.607 inches. Again, the biggest thing that people make a mistake right there. You forget to multiply by 12 to make it inches. Everyone wants to use just the 15. They want to plug that 15 in right for that L and be done. You can't, because this is inches, this is inches, this is also inches. So you have to, it has to be inches. You have to convert it into inches. So just make sure of that. And again, that cube only happens to the L, not anything else. So a couple other things to keep in mind is this number here is not going to be very big. So if you're getting numbers that are like the same or pretty close to like your length or larger, you probably did something wrong. This number is not going to be significant. You know, if it's maybe if the beam is 30 feet long and you have a 10,000 pound force on it and you don't have a whole lot of moment of inertia, it might be 30 inches. It's not really a realistic problem, but this number is going to be not a very significant number. It's going to be pretty small. So just pay attention to that. If you're getting numbers that are like the same as your length, you probably did something wrong. So check to make sure you converted to inches. Check to make sure you only cubed those inches. And just pay attention to that kind of stuff. That's some of the key areas that people make mistakes on. So good luck.